All right, this is example 3, verifying an identity. We're using double angle identities. And I actually think I'm going to do example 3 and 4 because this one is so simple. So just like with all of our other verifying identities, you want to start with the side that is considered to be the most complicated or complex side. In this case, I'm going to say that that is this side because it has both a cotangent and a sine in it, whereas this one is just cosine. So we're just going to verify that this also equals 1 plus cosine 2x. So what I'm going to do first is I'm going to turn cotangent into cosine over sine. That's one of our quotient identities, and that equals sine 2x. And that equals 1 plus cosine 2x. And I'm just working with the left-hand side right now, so I don't have to carry that down. I don't know why I did that. But so my sine x, in this case, I am going to use my sine 2x, my double angle identity for sine 2x. So let me scroll up here and look at it real quick. It's 2 sine cosine. So, and in this case, it's a on my examples, but in mine it's x. So I'm going to do cosine x sine x. And I'm now replacing this with 2 sine x cosine x. Now all of this is multiplication, so that could all be over 1, which means that that gets canceled. And so I have 2 cosine squared x. And that equals 1 plus cosine 2x. And if you go up and look at your identities, right here, cosine 2 squared a minus 1, if I add 1 to both sides, I get cosine 2a plus 1 equals 2 cosine a. So I have actually found it. So 2 cosine x is the same as 1 plus cosine 2x. So that equals that. So that's it for that one. So verifying an identity, I think they're getting, I guess, should be getting pretty simple. All right, so now we're going to use our double angle identities to simplify the expression. So if you look at this, it looks like one of our identities. So up at the top, I hope you have your identities listed there. I'm not going to scroll back up and look at it, but the identity is cosine 2 theta equals cosine squared theta minus sine squared theta. So that looks like this, right? Except instead of theta, I have cosine squared 7x minus sine squared 7x, which means that this is cosine 2, and instead of theta, it's 7x, which means I actually have cosine 14x. And that is simplified because it is down to just one trig identity, and that's all we were going to do is simplify. So in this case, let's see, sine theta. Okay, so this one looks like, sort of looks like, I am going to scroll up and look at this one. It almost looks like this identity right here, 2 sine a cosine a, but it not quite. So let's see, 2 sine a cosine a. So let me write that down real quick. All right, so my double angle sine identity is sine of 2a equals 2 sine a cosine a. Well, I have like what would appear to be sine a cosine a, but I'm missing the 2. So what I'm going to do is I'm going to rewrite this as 1/2 2, because 1/2 times 2 is really 1. So that's there, but it's like it's not really there. So then I have sine 15 cosine 15. So now that makes this look like that. So I could replace this piece of it, just this piece of it, with sine 2a. Now I can't replace the 1/2 but I can replace the rest of it. So I'm going to leave the 1/2, and I'm replacing the 2 sine 15 cosine 15 with sine 2 times 15, which is 1/2 sine of 30. And I know what sine of 30 is because I know either my unit circle or my left-hand trick or whichever one you're going to use. That would be 1/2. Sine of 30 is a half. So that simplifies to 1/4. And that is it for that one. Now, I know this first little piece here wasn't like, that maybe doesn't immediately jump to your mind. But now that we've done one, if you see something that looks very close to the identity, you're probably going to have to do something like that in the front. So hopefully that'll help.